Keep your OTR trucking business rolling. Make taxesfortruckers.com your partner to handle the money side. Taxesfortruckers.com can help you pay less taxes, keep your books, and track your finances to stay on the road towards your goals. Get started at taxesfortruckers.com. That's taxes, the number 4, truckers.com.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on Space Nuts. It's all about astronomy and space science. My name's Andrew Dunkley, your host. Great to have your company once again. On this episode, we're going to be looking at an asteroid that's been described as the fastest orbiting asteroid ever seen, or unseen, as the case may be, but they know it's out there. A space launch that only costs a few $100s. NASA would be interested in this, and it was in Australia. And we're also going to look at a new kind of telescope that will rival Hubble, and it will be held aloft by a helium balloon the size of a football stadium. Can you imagine? That's a lot of blowing things up. Plus some audience feedback and questions coming your way on this week's episode. And joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing?
I am well. How are you?
Yeah, good, thank you. This is the very last Space Nuts that will be recorded in Terry Hills, where we've been living for the last 11 years because we're moving. That's why there's cardboard boxes everywhere.
And this is Fred's solution to lockdown. How do we get out of this place? We buy a new house and move. It's a pretty expensive way of doing an outing, Fred.
It is. And it only takes us about 5 miles as well. So it's not that big a move. Never mind.
Well, good luck with it.
Yes, I look forward to be able to show you around the new premises perhaps next week.
Yeah, well, judging by all the boxes that you've got discreetly hidden behind you there.
I know.
It's not fun.
Much discretion.
Moving's not fun.
No. It's horrendous.
Dear. Well, we continue to be locked down here, and it looks like it'll be extended again. We don't know for how long. I'm hearing rumours that we might be locked down till the end of September because our numbers aren't declining in terms of new infections. So that's a bit of a worry. And the numbers in Sydney have been horrific. So we're sort of waiting patiently, or maybe not, for some answers on where we go to from here. But I know what the government is aiming to get to in terms of vaccination levels and then potential freedoms being returned, but we're nowhere near that yet. So we carry on, don't we?
We do. That's right.
Yes. Let's get down to business, Fred, and we're going to start off by talking about an asteroid. And this one's got a lot of attention because it's a bit speedy.
It's speedy, all right. Excuse me, the fastest orbiting asteroid ever discovered. And it's been discovered using a telescope down in Chile that normally does quite different things. This is it's quite an interesting, project. The whole story. There is a telescope similar in size to our Anglo-Australian telescope here at Siding Spring Observatory in northwestern New South Wales, which has a 3.9 metre diameter mirror. Down in Chile, operated at the Cerro Tololo Inter-American Observatory. It's actually an outfit belonging to NOIR Lab, which is the optical infrared, basically the National Optical Infrared Observatory in the USA. That is the Victor M. Blanco 4-meter telescope, and it's equipped with a camera. I don't know how many pixels your phone camera's got, but this one, Andrew, is a 570 megapixel camera. So it's a very, very wide angle camera using CCDs, the charge couple devices that we use. And normally what it's looking for or looking at distant clusters of galaxies to actually, and nearby clusters, but all the massive ones, because they're looking basically to try and understand the physics of the universe. And that's why it's called the Dark Energy Camera, or DECAM. So it's a great name. But once in a while, they turn it on the solar system. And in this case, what was happening was scientists were using the camera to probe the twilight sky. And by that, I mean the time either just after the sun has set or just before the sun has risen. Because even though it's not perfectly dark then, what you might pick up are objects which in our line of sight are very close to the sun. And sure enough, what they've found is an asteroid which rejoices in the name of 2021 PH27. A great name. I like it very much. It is the closest known asteroid to the sun. And what that means, of course, that the nearer you get to if you're in orbit around something, the nearer you get to it, the faster you have to go to stay in orbit. So this is whistling round at a speed which I haven't got a note of, I'm afraid, partly because it varies. It's in a very elongated orbit, as some asteroids are. And in fact, it crosses the orbits of both Mercury and Venus. So it's in this elliptical, elongated orbit, but actually its closest point to the sun is 20 million kilometers. That's about 12 million miles, which is 13% of the distance from the sun to the Earth. It's really it's almost shaving the upper layers of the sun as it makes that innermost passage during its orbit. So really an extraordinary discovery, and one that is of interest for further study, because if you've got something that goes that close to the sun, it's feeling an enormous gravitational pull. And so it's a great way of doing yet more tests of Einstein's general theory of relativity, because that becomes more noticeable. Its effects become more noticeable in strong gravitational fields. But also it means that this thing is feeling an enormous tide. And by a tide, what astronomers mean is the difference in the pull of the parent object, in this case the sun, on one side as compared with the other. That's what raises the tides on Earth. It's the pull of the moon being different on one side of the Earth from what it is on the other, and that's the effect that's the tidal effect. And with an asteroid that close to the sun, what it's doing is giving you some sense of how strong the asteroid is, because it's still intact, whereas tidal forces are trying to pull it to pieces, basically. And so you've got this nice balance between the what the tidal forces are and the structure of the asteroid. So a really interesting discovery.
Absolutely. I've just been trying to get some data on it. Its orbital period is 0.31 of a year. So what's that, about 4 months?
Indeed, that's correct. Yes.
So 4 months to do an orbit of the sun. Yeah. That's pretty schmick.
It's schmick, is that? Yeah. Its size is not yet known, I think. It's probably quite small because it would be pretty faint. Yes, as you said, 113-day orbital period. I don't think there's an estimate yet of its size.
Well, I've just gone to the great knower of all things, Wikipedia, and they've already got an article in there about it.
I bet they
and they say with an absolute magnitude of 17.7, the asteroid is expected to be larger than 1 kilometre in diameter.
There you go. So that makes sense, yes.
Yeah. But being sort of small and faint, as asteroids tend to be, was it pure luck that they found it? Would they have been really looking in the right place at the right time, hoping to find something?
Yeah, I think what my guess is that what happened was that the astronomers essentially were just using their twilight time of the night, probably at the beginning of the night, to check that everything's working all right and just to have a look. Because the camera, to do its job looking at clusters of galaxies, that dark energy camera, you really need dark time. That's to say the time when the sun's light is not affecting the sky at all, which means after the end of astronomical twilight, which means when the sun is more than 18 degrees below the horizon. So what they might well have been doing is just using the time between sunset and twilight to have a look in the vicinity of the sun and see what turns up. And sure enough, something did turn up, which is brilliant. They're looking. These guys are not. They're not amateurs. And don't use that term disparagingly, but they are not beginners. They're using. They're using what time they can to suss out what might be around. It's a great way to use a telescope.
Yeah, and apparently it was discovered by astronomer Scott Shepherd. And according to this article, the observations were conducted at twilight to search for undiscovered minor planets situated at low elongations from the sun.
Yeah, so that actually undoes what I just said, because Scott Shepherd is an asteroid hunter. He's on the team, and they're specifically looking for near sun asteroids. So
Right.
Forget all that, what I just said, total speculation. And the reason why I mentioned that is that we've done the same sort of thing. When I've been observing stars and galaxies with the surveys that I've been involved with a big telescope, the Anglo-Australian telescope, the twilight time, it's when you do your calibration exposures and things of that sort, but you're kind of waiting for darkness, and you've got this large telescope. Why not try and find something unexpected with it? That's kind of what happens.
Indeed.
Yeah.
And thus wraps up the Let's Embarrass Fred segment for another week.
Right. We do have one of those every week, which is fine.
We do. But the reference to a minor planet is interesting. Why do they call it that?
Because that's the technical term for an asteroid. It is. It's what asteroid was a term introduced by William Herschel back in the early 19th century. But astronomers have always regarded it as a slang word, almost. I mean, it's now not so. But throughout much of my career, Andrew, we talked about minor planets. And in fact, my master's thesis, its title is Practical Techniques for the Determination of Minor Planet Orbits. So there you go. Even back in the 1960s, it was still the official term. But now asteroid has become much more widely used, and it's kind of clouded slightly because we now have dwarf planets as well. We talk in terms of planets, dwarf planets, asteroids, which are rocky, comets, which are icy. The terminology has changed, but you can see from this article that yes, they're still called minor planets by the aficionados,
by the experts, by the asteroid hunters or minor planet hunters. Yeah.
Minor planet hunters, that's right.
So this one's pretty close to the sun and it's whizzing around very, very quickly. Do we know how many of them might be in that vicinity in these situations?
That's exactly the question that astronomers ask when they discover something like that. So you're right on the money there, Andrew. This is praise the Andrew segment.
No, it's the Andrew just got lucky with that question segment.
Yeah, that's right. And the thinking is there are probably quite a lot of them. Perhaps more to the point is, where did this thing come from? And there's a speculation that it could be a captured interstellar asteroid. Interstellar asteroids are among your favorite classes of object, thanks to Oumuamua, which was a genuine interstellar asteroid. But the thinking is that this might have been an interstellar asteroid that has got captured either by the gravity of Mercury or Venus. And what leads to that conclusion is its orbit is quite inclined to the plane of the disk of the solar system. I think it's 31 degrees or thereabouts, if I remember rightly. I did look at it. So it's got a tilted orbit, which suggests it might have come in at a funny angle. And it is even possible that it might be the remnants of a comet, with all the gas boiled off because it's so close to the sun. And what you've got is this loosely bound, dusty object, which is a comet-like orbit, although it's an unusual one because it's so small. It can't be that loosely bound, or else it would have fallen to bits by the gravity of the sun. So really interesting stuff.
Inclination is 31.662 degrees, so you're pretty straight. So he's redeemed himself.
Thank you.
Thank you.
That's good to know.
What might be the fate of it?
Yeah, that's another good question. Possibly in the end, a collision with Mercury or Venus, or even perhaps being captured. Wouldn't it be great if in a few billion years Venus has a moon in the shape of 2021 PH 27? That'd be great.
Wow.
That'd be fantastic stuff.
Anything's possible. Anything's possible.
Yes, that's
All
right.
right. Fascinating discovery, and maybe even some more work can be done on Einstein's theory of general relativity as a consequence of the discovery, which I think is also very exciting. So you never know what might turn up out there.
That's right.
This is Space Nuts with Andrew Dunkley and Fred Watson. Thanks for listening to the Space Nuts podcast. Before we get back to it, let me tell you about our sponsor, NordVPN. I've been using them for quite a while now, and I'm impressed. I'm not just talking about their service. I'm very impressed by their reliability and their speed. There are times when connecting to NordVPN is actually faster than my regular internet service provider connection, which I know is a big claim, but it's an absolute fact. And of course, there are lots and lots of benefits with a VPN service such as Nord. These days, you want a service that keeps you safe from hackers, especially when you're out in the public using public Wi-Fi services, which I've quite often done in the past, not right now because of lockdown, but again in the future. And for those who listen outside of Australia that aren't locked down, travel is opening up again, and you may spend a lot of time at an airport and you might be using your smartphone and log into the free Wi-Fi service. Well, if you do that, that's fine, except that you are also exposed to hackers, and they do spend a fair bit of time and effort hanging around airports trying to hack into people's systems. NordVPN can certainly stop that from happening because you can put it on your mobile device. In fact, you can put it on 6 devices at the same time. Your cell phone, your tablet, your home PC, your laptop, even your smart TV. You can put NordVPN on all of those and use the service on 6 things simultaneously. And that is really great protection. I've got it on all my devices. I'm surrounded by devices at the moment. 1, 2, 3, 4. I've got 4 things in here and they've all got NordVPN on them. Another great advantage is streaming. Geo-blocking is so common these days, and I've been caught, frustratingly so, trying to watch a TV on a US service, and I get a message to say I don't have access because I'm in Australia. Well, now I can just log on to a Nord server in the United States. Problem solved. It's really so simple and fast. And they've also got a smart system, so you don't have to pick a server for yourself. They'll pick the fastest and most convenient one and just, bam, connect you straight away. Now, if you'd like to take advantage of NordVPN, we can help because we have a special URL set up and a special deal for Space Nuts listeners. Just log on to nordvpn.com/spacenuts and you'll get a 2-year package with an extra 4 months thrown in for free. That's a damn good deal. 2 years and 4 months of cyber protection with the best in the business, NordVPN. Check it out today and reap the benefits of being part of the Space Nuts family. Go to nordvpn.com/spacenuts. That's nordvpn.com/spacenuts and sign up for your future security. Now let's get back to Space Nuts.
Roger, you're loud and clear here also.
Space Nuts.
Hello again to our patrons. These are the people that put a few dollars into the Space Nuts podcast every month, and they do it voluntarily. We don't hold a gun to their heads or a laser or whatever it is. But we do appreciate you very much for supporting Space Nuts. And if you'd like to learn more about doing that, you can jump on our website and there's a Support Space Nuts button where you can learn about the packages that are available and the options for supporting Space Nuts, and you can check out the Space Nuts shop while you're there. Oh, by the way, for those of you watching on YouTube, guess what turned up for me this week? How about that? It's the Space Nuts mug with the Space Nuts logo on it. So I think there's one headed your way, Fred. So it should... Hopefully it'll turn up before you move. Oh, dear. Yeah. Yes, check it all out at spacenutspodcast.com or spacenuts.io. Now, Fred, let's move on to our next topic. It's a double bunger because they're both kind of related and involve balloons. This first half of this segment looks at some work at La Trobe University in Victoria in Australia, where they've done a space launch and it only cost a few $100s.
Yeah, isn't that great?
Yeah.
La Trobe University has a team which is called the High Altitude Advanced Materials and Engineering Research Team, or HAMR, which I like. It's HAMR, actually, H-A-M-E-R. That's a nice acronym. And this team has invested, yes, a few $100s, probably more, because they've got 24 of these balloon-launched missions planned over the next few years. And the very first one, last week, basically celebrated the success of their first launch. And, you know, the balloons are, in many ways, they're an unexploited technology for high-altitude research, whether that's looking out into space or looking down at the Earth's surface. I know, so you remember when Marnie and I used to take tours up to the far northern Arctic. In Sweden, there is a place called Esrange. It's the Swedish Space Research Institute. That's their launch site. And they not only launch rockets there, but they also have a very strong balloon program. And I got quite keen on that at the time when we were going up there, because it's such a cheap way of getting to heights of 30, 40 kilometers, maybe more, when you're above, you know, almost all of the Earth's atmosphere. Not all of it, or else the balloon would come down. But you're above much of the Earth's atmosphere. And you can do it for budgets which, as the La Trobe University team here in Australia have described as a few $100s. The interesting thing about balloon flights, of course, is that the balloon actually is carried by high-altitude jet streams. So the balloons tend to fly around the Earth. We've seen examples of that. In fact, human occupied balloons have flown all the way around the Earth on the jet stream. So you've kind of got to be careful where you launch them and where it comes down. And I'm sure I read somewhere with the La Trobe launch that they are, that's right, they're tracking the landing, and I don't know whether it's landed yet. It may have touched down already. But the quote I've read is that they're expecting it to end up between Bendigo, Shepparton, and Wodonga. And the leader of the team said that the launch pad spot was chosen to make sure the balloon didn't land in New South Wales, because New South Wales is in strict lockdown. And so, they don't want the balloon to fly into New South Wales and then come down, and then they get told at the border that we can't chase the balloon, he said.
See, they're cutting it fine if it comes down at Shepparton.
Yeah, I actually have to say I'm not that familiar with the geography of that part of Victoria, but Wodonga's right on the border, isn't it?
That too. Yeah. Well, it's all kind of in that little cluster there.
Yeah, so we'll have to see what happens with that. And the other thing I liked about this story, and this also ties in with the Arctic expeditions, the main reason for this first test flight, and this is another quote from Professor James Maxwell, what a great name in science, who's part of the La Trobe University team. The main reason for this test flight was to see how many hand warmers the balloon needs to keep the batteries warm. Because the lithium batteries, if they get cold, they just die. And they're using those chemical hand warmers. Now, we use those quite often up in the Arctic. You stick one in your glove, you open them up, stick it in your glove, and it stays warm for about 7 hours or something. So the test flight's all about how many hand warmers you need to keep the balloon warm in the future, which is brilliant stuff. Lovely experimentation there, and doing it on a shoestring budget.
Yeah, and that's where the extra hundreds of dollars came into
with the hand warmers.
The hand warmers,
yeah, maybe so.
And Shepparton is very close to the New South Wales border.
Okay,
and Wodonga shares the border
You're
with
right on
Albury,
it.
which
Yes,
is in
that's
New
right.
South Wales. So, they've got a tight window.
Yeah.
Pretty tight window. Of course, the thing's got high-definition cameras on it and GPS locators, so they'll know where to find it. And it obviously is been up there to take footage. I don't know particularly what they wanted to look at. I guess it just depends on which way it spins and dangles.
Yeah, I think at this stage I don't know. I shouldn't, I shouldn't speculate again because I've already got into trouble for that once today. But if I was launching a balloon like that for the first time, I'd just take what came from the camera. The thing is, the technology exists already to accurately point cameras for astronomy from balloon-mounted platforms. So it really is, I think, a big advance. And maybe that's the segue into the other half of this segment, Andrew.
Absolutely is. This is a story out of Toronto, and this is a huge scale compared to what we've just been talking about. This is sending an observatory aloft on a balloon the size of a football stadium. I mean, this is deadly serious stuff. Probably cost a bit more than a couple $100.
It will, but it'll still be cheaper than sending up a spacecraft, on a rocket to put it into orbit. And what we're talking about is the SuperBit. And I think the BIT part of the name is Balloon-Borne Imaging Telescope. So there's two B's there, but never mind. The Balloon-Borne Imaging Telescope, the SuperBit. And that's, as you said, been announced with collaboration from Princeton University, Toronto University, and the University of Durham in the UK. I used to work very closely with scientists at the University of Durham when I was building instruments for the observatories in La Palma. That's another story. So what they're doing is, they've teamed up with the Canadian Space Agency, which is one of the members, of course, of the International Space Station, one of the member agencies, and an outfit called NASA, of which you may have heard, to build this new sort of telescope. And as you said, the football stadium-sized balloon. Of course, it's only football stadium-sized when it's at altitude, because these things, when they're launched, they just look like a strange empty bag with a bit of puff at one end that takes it up into the atmosphere. But as the pressure outside reduces, the balloon swells. So, it goes to be the size of a football stadium and actually has on board a camera. Now, I think it's a 0.5 meter diameter telescope that feeds the camera. That's considerably smaller than the Hubble, but at 40 kilometers altitude, which is where this thing will operate, it has the same high resolution, or similar high resolution. It won't be quite the same, but it'll be very similar to the Hubble Space Telescope. And the estimated cost for the Hubble Space Telescope so far is in the region of $10 billion. And this is going to be done once again for budgets which are measured in thousands of dollars rather than even millions, I think. Actually,
that's amazing.
I'll correct that, because it's not. It's more than $1 million. It's about $5 million US dollars is the budget, but it's still much better than $5 billion, which would be sort of a Hubble scale instrument. So this is really very interesting, and one of the aspects of this that's I think very advantageous is this thing comes back to Earth. So you can tweak the design, you can put right anything that's gone wrong, and you basically can carry out repairs or whatever because you do get it back. Whereas with spacecraft, everything has to have redundancy built into it, so that you know that there isn't a showstopper, and that redundancy is very expensive. I mean, think of the James Webb
yes, I
Space
just
Telescope,
was.
which
Yeah, once it's out there, it's out there, and if something's wrong,
it's absolutely out there. Yeah, there's no way. A million
and
and
of
a
course
half kilometers away.
we remember Hubble had some issues early on, and
Yep.
they had to do a space shuttle mission to fix it. Which
That's correct. They did.
and just a bit of
they
sticky
did,
tape
indeed.
did the job there. Sticky
And
tape's
Hubble's
universal.
altitude, it was optical sticky tape, but that's effectively what
that's
it
right.
was. Yeah. Hubble's orbit, I think, is, if I remember rightly, is about 600 kilometers or maybe 700 kilometers, which is unattainable with present day human spacecraft. The shuttle could do that, but I'm not actually sure. I might be wrong there, because maybe Crew Dragon can go to those altitudes, and when it flies, perhaps Starliner might be able to as well. But my impression is that they're meant for lower Earth orbits than that.
And how long a period will this thing stay aloft? If they can retrieve it, and obviously with a balloon, it's not going to stay up there forever. But are they expecting it to be able to do longitudinal missions, if you like?
Yes, I think so. I think I'm not really sure of the details of what they're planning with this, but my guess is that it will be aloft for long periods, and maybe a week or something like that would be a long period in this case, or maybe even longer. But what they're planning to do is charge up the batteries while it's in daylight, and then use the the energy that's been stored in the batteries to make the observations during the night. I can't find a note of what a typical mission time might be. So okay. Here's a bit of text that really relates to this, because there's this technology now developed by NASA, and this is the breakthrough here, Andrew, that lets the helium stay within the balloon for months.
Wow.
So NASA has basically developed what they're calling superpressure balloons, and that's where the super bit comes from, the super bit of superbit. They can contain helium for a long period of time, because that's been the limit. That helium, like hydrogen, tends to find its way out of balloons. You know that yourself. If you buy a party balloon, it only stays up for a day or two.
Yeah.
But with this new newly developed technology, so we might expect there to be several circumnavigations of the globe. That's basically the time that the sort of thing they're talking about. So yeah, fabulous stuff.
Wonderful indeed. Yeah, and all for a small percentage of the cost of sending something like the James Webb or Hubble into space. So could provide a new opportunity, and might change the way we do things in the future to a certain degree anyway. This is the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
And thanks for joining us. I hope you're enjoying the program. Andrew Dunkley here with Fred Watson, talking astronomy and space science. And Fred, we're going to take a couple of questions, although one of them is probably big enough to be an entire segment. But we will get to that. But our first question comes from one of the coldest places in Australia.
Hello, I'm from Hobart in Tasmania, and I've been listening to podcasts for about a month now, and I've really been enjoying it. So anyway, to my question, I've heard about the possibilities of harnessing the abundance of hydrogen in the atmosphere of Jupiter to refine into fuel. Would it be possible to capture the hydrogen when you're aerobraking through the atmosphere, using it to correct your orbit once you get to the highest point, essentially resulting in a free orbit? I was thinking about this a while ago and wanted to test that in a Kerbal Space Program, but unfortunately you can't suck stuff in from the atmosphere of Joule in the game, Joule being the green equivalent of Jupiter in KSP. But anyway, yeah, thanks.
Okay. Capturing hydrogen during Jupiter orbit, is that what I heard?
So aerobraking, which is using an atmosphere to essentially to slow down the motion of a spacecraft. It's used in Earth orbit considerably. That's what allows, human capsules or the space shuttle to get back to the surface of the Earth. It's a neat trick, Andrew, because if you think about it, if you try to use rocket braking to bring back your spacecraft, you'd need nearly as big a rocket as you got to launch it. Although, of course, the fuel is gone. But so aerobraking is the trick. It's the neat way to re-enter an atmosphere or enter an atmosphere of a planet. And aerobraking's been used on Mars as well many times. So using it on Jupiter, it's something that you could use to modify the orbit of a spacecraft to put it into orbit around Jupiter rather than try and land on Jupiter, because there's no known surface, the base of Jupiter's atmosphere. And whether you could actually collect hydrogen on the way down is a really interesting suggestion. Because the atmosphere, yes, there is a lot of hydrogen in Jupiter's atmosphere. Aerobraking tends to be a fairly hot sort of process because you've got the heat, the frictional heat, which is actually not caused by friction. It's caused by the compression of the atmosphere in front of the spacecraft. There's a lot of misinformation about that, which I've been guilty of spreading myself many times. But you've got to dissipate the heat somehow, and that means in the case of the shuttle, it was heat-resistant tiles, which essentially dissipated the heat. On capsules like the Orion capsule, which is being developed by NASA, and the SpaceX Crew Dragon, it's a thing called an ablative shield. It's a resin, a plastic resin that burns away to dissipate the heat. Or it evaporates and carries away the heat. So whether you can collect hydrogen under circumstances like that is a really interesting prospect. There will be some fascinating physics involved, which are well beyond me at the moment. But I'm sorry I don't know the name of our listener. But it's a great idea, and I think could be built into space games, if not reality.
Could do. Yeah. Probably a dumb question, but if you are aerobraking and creating that compression which builds up heat in a hydrogen environment, wouldn't that cause an explosion or some kind of?
I wondered if you'd ask that, because it crossed my mind as well. So I'm glad you did. And the answer is that you would need oxygen to cause an explosion.
Oh, of course.
And so you don't have it in Jupiter's atmosphere.
No.
It's probably a bit, but not enough.
Yeah. Okay. That makes sense. All right. Thanks for the question. Sorry we don't know your name, but we appreciate you joining the ranks of the Space Nuts fraternity. Greatly appreciate it. Okay. To our next question. And again, they say their name, but I just can't catch it. But it's all becomes self-evident. It's a fairly long question, but it creates an interesting discussion that we do love this subject. So here we go.
Yeah, hi. My name is Fenton Hertzler, and I'm calling you from St. Paul in Minnesota in the U.S. And I wanted to get back to you on the where is the goo, or spreading the goo question that you had. In other words, does life exist elsewhere? Is it intelligent life? Is it just a bunch of bacterial smudge? Now, I'm a chemist. I'm a pretty dogmatic chemist, and my specialty is self-assembly. That is how non-bonded molecules come together and form organized structures. Okay, so we have Dr. Bettel Kretschmer, and she has one opinion, and I'll point out that we have an example of evolution right now over a period of 2 years, and that's the COVID vaccine. It's already mutated several times, and its behavior has also changed and how it interacts with us. And then we have evolution over the period of many millions of years, hundreds of millions of years, and I've I wouldn't be surprised if a COVID virus becomes intelligent over that period. In other words, you start small on the basis of molecules or rather viruses and bacteria, and you end up with intelligent life. It's just a logical physical principle. Okay, you'll remember the Dunning-Kruger saying originally started with Shakespeare, and that says that everyone who thinks they're an expert is actually a fool, and everyone who's humble and modest and says, I don't know what's going on, and actually has a respected and well thought out opinion. So you can take your choice as to what I'm saying here and whether it has any validity. Now, there's another question I had as a chemist, again, as a dogmatic chemist, and that relates to what constitutes life and whether life here is chemically possible someplace else. Take, for example, the moon Titan, which is notably colder than Earth. So that means that chemical reactions which occur on Earth will not occur on Titan. And that means that you're going to have a totally different regime of stability. Molecules that would fall apart on Earth are stable on Titan. They could form the basis of self-organization and hence life, albeit, as the saying goes, not life as we know it here. And on the other side of the coin, say imagine you've got a very hot place, say not like Venus, but someplace it's hot, you're going to have reactions that won't occur here on Earth, but will on that hot planet. And that would give you, conversely, a different form of life, which is more based and more in tune with the temperature elsewhere, as well as other chemical principles, whether you have an acid or a base and how much metal ions you have, things like that. Anyway, I really appreciate your show. It's great to wake up and get your brain going with. You can count me as someone who will never miss one broadcast. It's much more thought-provoking than listening to the stupid news nowadays. So, thanks, and I hope you have a second to put some of my thoughts in your broadcast.
Well, we've put all your thoughts into our podcast, but thanks for bringing up so many angles on a topic that we do regularly focus on, and that is life beyond Earth. Now, that question, spreading the goo, came from something Rusty in Donnybrook brought up a few weeks ago about seeding the universe with life and whether or not we should do it and whether or not it would work. And this is sort of adding to that theory. And he brought up COVID or coronavirus as something that, if it had time to evolve, would become intelligent. That's an interesting thought.
Yeah, I'm not sure. I mean, the debate is, I think, ongoing in the world of biochemistry. Is a virus life? But it clearly evolves, and it does need a host, but it's in that regard, it's self-sustaining and self-replicating. It fits one definition of life. But the question of whether you give something like that, okay, let's assume that you've got some organization of molecules that generates something like DNA and eventually generates perhaps microorganisms like bacteria. The question of whether that will evolve inevitably, if you leave it long enough, into an intelligent species is a really vexed one, I think, in the world of astrobiology, because 40 years ago, in fact, longer, let's say 60 years ago, when Frank Drake first proposed the Drake equation and put numbers in, at that time it was assumed that any living organism of the most humble kind would eventually evolve inevitably into something with intelligence. And that view is not shared today. There's certainly a common strand that says the step to get from a single-celled organism to a multi-celled organism is such an energy-hungry step that it would only happen under certain circumstances. And so that, that's why I think a lot of astrobiologists think that microbial life might be common throughout the universe. And I hope we find it soon if that's the case. But that higher order life, and not just intelligent life, but things like plants and, pretty rudimentary animals, might not have made it because of this huge step there is to overcome in order to turn life into a single-celled organism into multi-celled organisms. So, a really interesting argument, which doesn't have an answer really, because we won't know whether there's intelligent life or advanced life out there until we find it. And the thing is, if we don't find it, we'll never know that it's not there because there's so many places to look. The other part of the question, though, or the comment, is a really good one, and I think really interesting in that chemistry is driven very much by temperature, and you get completely different reactions at different temperatures, and I think those points are very, very well made in the comment that you've just played, and I think, however, leaping to the defense of the astrobiology community, I think they take that on board. Those people who look at the prospects for living organisms elsewhere in the universe. I mean, certainly, the idea of living organisms on Titan that use ethane and methane as their working fluid, or ethane and methane, depending on how you pronounce it. Hydrocarbons, in other words, the same sort of hydrocarbons that we find in natural gas on Earth. That would be a completely different chemistry. It's taking place at minus 200 degrees Celsius. The reactions that are common on Earth perhaps wouldn't occur down at those temperatures. But I think the astrobiologists have looked at that. They've tried to figure out what these things might breathe and what they might eat, and what organisms they might represent. And I haven't seen anybody writing about it, but it also occurs to me that maybe you could get, at the opposite end of the spectrum, you could get living organisms that have iron as their working fluid, because they're at temperatures where iron is molten. That might put a whole different kettle of fish on the biochemistry of those, because iron is a metal, of course, and has a different chemical property from the other things that we've talked about. So really interesting thoughts there, and a great question if that's what it is, but I think it's more a comment which is very welcome. We welcome comments of any kind.
Yes, indeed.
So thank you.
Yeah, appreciate it. And it's always thought-provoking to consider life as we know it may not actually be life as it is elsewhere. If it's out there, it could be so very different to anything we could imagine. And we've talked in the past about what life would be like under different kinds of stars. We take for granted the environment we live in. The trees are green, the sky is blue, et cetera, But, if you're orbiting a life-bearing planet on a blue giant, wouldn't be the same. It'd be a completely different set of circumstances, and everything would change. And even the colour of the trees, things like that. It really gets your mind going. I love it. I really do. And I hope they sort things out on Perseverance and it learns how to dig a hole, and we can get some dirt that might show that there was once, or may still be, some kind of microbial life on Mars. Who knows? Well, we hope to know very soon. That's the plan, indeed. That brings us to the end of another show. Fred, thank you so much.
It's a pleasure. And I look forward to talking to you next week under quite different surroundings, I hope, anyway.
Yes. Can't wait to see the new digs.
No, me neither.
Good on you, Fred. Thank you so much. Professor Fred Watson, part of the team here at Space Nuts. And don't forget, if you'd like to get in touch with us, go to our website. There's an AMA tab up the top where you can send us an email, or you can just click the little button on the right to send us a voice message or a question, whatever you like. It's spacenutspodcast.com or spacenuts.io. that's where you'll find us. Thanks again for listening. It's been great fun, and we look forward to catching you on the very next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.